to the edge. All my friends are dead. Push me to the edge. All my friends are dead. Push. I'm not even looking at the camera. I'm just looking at myself because you know I'm just never mind. So you know what it is, you know what it ain't. When you in this thing, about to get crunk. Eyebrows on black. Okay. So you know it's me and Jordan video on the Atomic Theory. So like and subscribe and comment for more and get us to 4 million views. You know how we go. Now, without further ado, on to the video.
Anyways, hey guys, it's Jordan, and today we're going to be talking about dead white men's atomic theory. Okay, you're probably sitting here like, why is this important? Well, the topic is important because it gives basic knowledge of the beginning of atoms and such, and that we can also note visible changes between each model and theory. So, for example, Rutherford and Bohr. And you're probably also sitting there like, how is this used in chemistry? Well, dead white men's atomic theory is used to explain properties or behaviors of atoms, and it's based on available evidence to suggest future lines of research about atoms. So, anything that you need to know prior to learning about atomic theory is what an atom is. So, an atom consists of a heavy central nucleus surrounded by a cloud of negatively charged particles called electrons, and that the nucleus contains protons and neutrons. Let's get it.
Now it's time. Okay. Now it's time for my man, Democritus. Yup. So my man Democritus, he was the originator, born in 450 BC. He was the originator of this whole thing. He started it off as the name Atomos. You know, 450 BC, they old-fashioned. They old-fashioned. So he came up with the idea that atoms, atomos, was tiny invisible particles. So it looked like this. Do that make sense? No. So we're gonna get some more into the development of the atom. Dalton, you know, he was 1766 through 1844. Go back in your notes if you want to check it out. So he agreed with my man Democritus, and he said that matter is indeed composed of atoms. But he also came up with the 4 postulates that we now go by. Each element is composed of extremely small particles called atoms. All atoms of one element are identical. That means it's not like atom A, atom B, atom A, atom B, atom C. It's not like that. And atoms are neither created nor destroyed. So it can't be an explosion and then it'd be like boom atoms or boom no more atoms. It's atoms all around. And a given compound also always has the same relative numbers and kinds of atoms. So Dalton thought atoms were hard, round, solid balls. So he sounded real good up until that last bullet point, right? This is what my man Dalton thought that atoms were. Nope. That ain't right. It sounded real good, right? Yeah. Then nope. Nope. So last but not least is my man J.J. Thomson, kid. Dynamite. You know, he had to come hard for that one. So my man J.J. Thomson, he say that, let me get into it. Hopefully it's talking. He discovered and named electrons. So you know my man was fly. He defined electrons as particles with a negative charge. Okay, key point. Write this down. You know. He performed the cathode ray tube experiment. That will be important. later on in this video. He said an atom was a ball with electrons and protons evenly spaced throughout the atom. So that sounds right? This is what my man J.J. Thompson came up with. Okay, we getting somewhere. We not just looking at empty balls now, right? So remember that key point that I just gave you. And the man of the hour, Rutherford. He ain't get as much as I wanted, but he got it. So we're just gonna keep it moving. Alright, so my man Rutherford discovered and named the nucleus. So now you understand why this man is so important and why he the topic of this video. So protons and mass concentrated at the center of the atom, which is what makes up the nucleus. All atoms have a nucleus, so they pretty important. Atoms are mostly made up of empty space. So half of this was right, but wasn't right. Half of this was right, but wasn't right. Yeah. So, my man, he also performed the gold foil experiment. For those of you that don't know what the gold foil experiment was, my man Rutherford, he sound bougie, don't he? He was gold foil, and my man was bougie. So, I'm gonna lay down some facts about my man Rutherford. He most known for his gold foil experiment, which shot alpha particles through very thin pieces of gold foil. Okay. Prediction for this experiment was alpha particles would travel in a straight line through the foil, mostly unaffected. The result was mostly accurate, but some particles were deflected in large angles, like Star Wars, like zoom, zoom, that stuff. So the conclusion: the atom must contain a positively charged core, which would be protons in the nucleus, surrounded by mostly empty space and negatively charged electrons. So the nucleus is like the positive part, and the electrons are these things. So like I said, my man came up with the nucleus. So he pretty important.
I was looking at you and you was looking at me and we was thinking, Go to market, go to market, go to market.
Go Rutherford, go. Now pop with it. Hey. Okay, so Jaya got into what Rutherford did, but here's an example of how his atom looked. Yeah. You got my man, this boy, 8562, protons, neutrons, electrons in there too. A's for atom. Okay, let me stop. Okay, so Niels Bohr version of this atom shows the orbitals and the electrons on the orbitals. Also, Niels Bohr discovered that electrons exist in energy levels and that electrons only have certain energies that they are quantized. So, pretty much, my man Niels Bohr was like, my model's better than Ernest Rutherford's. I mean, like, look at this. He probably was like, oh no, baby, what is you doing? We still use this model today. So, good job, Niels.
Who first proposed an atomic theory based on scientific knowledge? Could it be A, John Dalton, B, Jöns Berzelius, C, Robert Brown, or D, Dmitri Mendeleev?
Answer choice A. Basically, John Dalton expanded upon an atomic theory proposed by Democritus. Answer choice B. Jöns Berzelius, he conducted pioneering experiments in electrochemistry and established the law of constant proportions, which states that the elements in inorganic substances are bound together in definite proportions by weight. What does this have to do with atomic theory? C. Robert Brown. Well, the only Robert Brown I know happens to be Bobby Brown from New Edition.
You know, where he sings the song. They say I'm crazy. I really don't care. That's my prerogative. Last but not least, answer choice D is Dmitri Mendeleev. And basically, Mendeleev arranged elements according to atomic mass, which increases. So, out of these 4 answer choices, answer choice A, John Dalton, first proposed an atomic theory based on scientific knowledge because he went off of Democritus.
So, in the gold foil experiment, most of the particles fired at the foil, A, bounced back, B, passed through the foil, C, were absorbed by the foil, and D, they were combined with the foil. Answer choice D, combined with the foil. If you thought this was the right answer, you're wrong. Answer choice C, they were absorbed by the foil. Answer choice B, passed through the foil. So, if you were listening to Jaya earlier, then you would have known that it was answer choice A and that the particles bounced back. Because bounce back, bounce back. So the answer choice A is correct. If you thought B, C, or D, I don't know what you were thinking. You're wrong.
Alright, so you know how this go. You know we gotta finish this video so I can get a good grade. So first we're gonna start off with the open-ended question. Yeah. Thank you for that. Thank you. Alright. Okay. So you know we coming in with the open-ended question. And our open-ended question is as follows. How did Rutherford's gold foil experiment work, and what did this experiment prove? So I'm gonna get into him later in this video, but as of right now, you know we gonna outro with some music. Yeah. Back to our open-ended question. How did Rutherford's gold foil experiment work, and what did this experiment prove? Alright, I'll give y'all some time. That was a good 10-15 minute break, you know. Yeah, no. Now we coming through with the answer. Yeah. Yes. Alright. So your answer is to the first question, which was how did the gold foil experiment work? Rutherford shot radioactive particles through gold foil onto photo paper. He expected all of the particles to go straight through, but some bounced back. Alright. So the second answer to the second question, which was what did this experiment prove? This experiment proved that there was a positively charged, very dense center core called the nucleus, which was surrounded by empty space and all electrons. So we at the end of my part of this presentation, and you know we gonna stop it here. So it's been an honor serving y'all today, and
Isn't love? Why do I feel this way? Why does she stay on my mind? And if it isn't love, why does it hurt so bad? Make me feel so sad inside. Guys, we're about to be juniors. This is unreal, to be honest. We're about to be able to get the opportunity to walk out of the front door and say, I passed this class. But anyway, to recap this video, it was about the dead white men's atomic theory. And it's important because it gives basic knowledge of the beginning of atoms and such. And we can note the visible changes from each model in each theory. 2019, we out.